Exam question revision video for GCSE quadratic in context. So the question, we're throwing a ball upwards from a certain height and they're giving us a formula to show what the height is after a certain time. So what do we think about this question? Well, first of all, there's a squared term, so we're probably dealing with a quadratic equation. For part A, they give us the height, so we can replace h by that in the equation and see what happens. So that means we have, instead of h equals 1 plus 8t minus 5t squared, we have 4, which is the height, equals 1 plus 8t minus 5t squared. So if we're aiming for what they're asking us to show, then we need to get everything onto the left hand side. So first we add 5t squared to both sides, which gives us 5t squared plus 4 on the left and gets rid of the minus 5t squared on the right. Then we subtract the 8t, which gives us 5t squared minus 8t plus 4 equals 1. And finally we subtract the 1 from both sides, and that gives us what we need, which is 5t squared minus 8t plus 3 equals 0. And just another reminder, I'm sure you're being told this all the time, always do the same to both sides with equations. Okay, so part B, we have to solve this equation. And what do we think about this? Well, we could use the quadratic equation formula, which is on the front of the exam paper, but it would be quicker to factorise if we can. So let's have a look at this. Well, we're going to have brackets with something t plus or minus something times something t plus or minus something. So if we look at the first terms, these are the t terms being multiplied together, they must give us our 5t squared. So what numbers could we have where those little blobs are? Well, the only two whole numbers that multiply to 5 are 1 and 5. So we'll go for that. So that gives us 5t in the first bracket and t in the second bracket. The next thing to look at is the last numbers in the brackets. So these two need to multiply to plus 3. And that gives us two choices. We've got 1 times 3, which is obviously 3, but we could have minus 1 times minus 3 equals 3. And actually, seeing as we've got minus 8t in the middle, we need some minuses in there, so it's going to be the minus 1 and the minus 3. Now it could be that way round, or it could be the other way round. So we've got to check both of them. So let's have a look at the first one. Well, we've got the outer and the inner multiplications to do. So we have 5t times minus 3. So that's 5 times minus 3. And we have minus 1 times 1 for the 1t. So that's minus 1 times 1. And that gives us 5 times minus 3 is minus 15. Minus 1 times 1 is minus 1, which gives us a total of minus 16, which would be the coefficient of our t term. And we need minus 8, so that's no good. So it must be what we've got written at the bottom, but we need to check. It could be that we can't factorise it. So we'll do the outer inner again. And we get 5 times minus 1 for the outer and minus 3 times 1 for the inner, which comes to minus 8, which is what we need. So that's the correct expression, 5t minus 3 times t minus 1. So we haven't finished yet, because what we need to do is to put that equal to 0. Now, if two brackets multiplied equals 0, then one of the brackets must be 0. So that means either we've got 5t minus 3 equals 0, or we have t minus 1 equals 0. There's no other way for two numbers multiplied to give us 0. Okay, so solving the first one, we add 3 to both sides, which gives us 5t equals 3, and then we divide by 5, which gives us t is 3/5. But the second one is nice and easy. You can probably see straight away that t must be 1, but if we write it down, we would add 1 to both sides, and that gives us t equals 1. Okay, so we've now solved it, but what if you think to yourself, I can't see how this will factorise, or you can't work out the factorisation? Well, in that case, you could use the formula. So let's have a look at that. And it's worth looking at this as well, even if you're good at factorising, because it may be that you're instructed to use the formula in some question or other. Okay, so we have our quadratic there, and the first thing we need to do with the formula, I wonder if you can think about what that is. Well, the formula uses a, b and c, so we need to identify them. A is the coefficient of t squared, b is the coefficient of t, and remember you must include any minus signs in that, and then the c is the constant term, again making sure you include a minus if it was there, so worth putting the bracket round the plus. Okay, there's the formula, copied if you like, or if you've learnt it, fine, but you can check it on the front of the paper if you need to. And we then pop the numbers in. And first of all, even though we know b is minus 8, we know we've got minus b, so minus 8 is 8, it's not a bad idea just to copy the formula out with the numbers put in. The next thing we do is gradually tidy it up, so minus 8, as I just said, is 8. Minus 8 squared is plus 64, remember minus times minus is plus, and then 4 times 5 times 3 is 60, 4 times 5 is 20, times 3 gives us 60, and 2 times 5 is 10. So carrying on, we've now got 8 plus or minus the square root of 4, obviously 64 take away 60 is 4, and that means we've got 8 plus or minus 2 on the top, and we've still got our divide by 10. So now we've got two possibilities. We either have 8 plus 2 over 10 or 8 minus 2 over 10, and 8 plus 2 is 10, and 10 divided by 10 is 1, 8 minus 2 is 6, and 6 divided by 10 could be converted to 3/5. You could convert it to 0.6. I don't think it specifies that you need to give a fraction as the answer, so you could give a decimal. Okay, so that's using the equation. Now, there is a final possibility, which is for somebody who struggles with using the formula, may be a bit worried about the calculations that are required, even though we've seen they're not too bad, and also isn't able to factorise it. There is always trial and improvement to fall back on. So we'll see whether that's a good idea. So first of all, we make a table. I haven't bothered putting lines in, but you might like to. But we've got values of t, and then we're going to work out what 5t squared minus 8t plus 3 is for particular values and see what happens. So if we put 1 in, which is not a bad place to start, we get 5 times 1 squared, take away 8 times 1 plus 3. That is 5 take away 8 plus 3, and that's 0. So we find that t equals 1 is actually a solution. So that's quite neat. And in fact, if at this point you started doing trial and improvement, you might just think that that means one of the brackets needs to be t take away 1. Because t take away 1, if we put the value of 1 in, gives us 0. And so multiplying the other bracket would still give us 0. So that might give you a chance of doing the factorisation. But assuming that doesn't occur to you, or you're still not wanting to do a factorisation, we'll carry on with trial and improvement. So let's go below 1. Try 0. Well, that's not too difficult. 5 times nothing squared minus 8 times nothing plus 3 is 3, obviously. And then we might go above 1 and see what happens. So we'll try 2. And we have 5 times 2 squared minus 8 times 2 plus 3. 2 squared is 4, times 5 is 20, 8 times 2 is 16, and then the plus 3, and that gives us 7. So at this point, we've got to decide where to go with the trial and improvement. With ordinary trial and improvement, we're just aiming for one target. Now we've found one target, as it were, when t is 1, that gives us the 0 we need, but we don't know yet which side of 1 the other one is. Is it smaller than 1? Is it bigger than 1? So, not sure what to do. So, good idea in this sort of situation is to do a little sketch and see if that helps us. So, here's the situation we've got. We have our 1 and our 2, and obviously our 0 is on the axis there. So, when we have 0, we get the value 3. When we have 1, we get the value 0, and when we have 2, we get the value 7. So they're just marked on roughly. And now, because both of those values are above 0, the 3 and the 7, then that means the other place where this quadratic can cross 0, which are the values we're looking for, must be either between the 3 and the 1 or the 1 and the 2, because it can't go back down again once it's got up to 2 and up to 3. You'll see what I mean in a second. So if the other values between 1 and 2, the shape of the quadratic would have to be something like that, and we know that quadratic graphs are symmetrical. So that's looking unlikely. On the other hand, if we look between 0 and 1, then we can see that it's easy enough to sketch one that's close to being symmetrical, and so it makes sense to try values between 0 and 1. Okay, so here's another table, and we try 0.5. That's the obvious thing to do, is go halfway between. So 5 times 0.5 squared, take away 8 times 0.5 plus 3. 0.5 squared, a half times a half is a quarter, so that's 0.25. So we've got 5 times that. 8 times 0.5 is 4, of course. And 5 times 0.25 is 1.25. Take away the 4 plus the 3, and that gives us 0.25. So that means that our value, because that's above 0, that means the value we're looking for must be between 0.5 and 1. So let's try 0.6. Now we might normally choose to be more like halfway between, so try 0.7 or 0.8, but 0.25 is the value we get when we put 0.5 into this formula. So I'm thinking 0.6 is probably the better chance. So let's put 0.6 in. So we've got 5 times 0.6 squared, take away 8 times 0.6 plus 3, and that equals 5 times 0.36, take away 4.8, 8 6s are 48, so we get 4.8 plus the 3. Now 5 times 0.36, there's a neat way of doing that. We could double the 5 and half the 0.36 without changing the multiplication. That gives us 10 times 0.18, which gives us 1.8. So we now have this 0.6. When we put that into the formula, we get 1.8, take away 4.8 plus 3, and that is 0, because 3 plus 1.8 is 4.8. Take away the 4.8, we get our 0. So that means our answers are t is 0.6 or t is 1. But I hope you've got to this point and thought this is harder than using factorisation or the formula, so make sure you do plenty of work on those two things before the exam, because you don't want to have to fall back on trial and improvement in a situation like this. Okay, part C at last. Interpret your answer to part B in the context of the question. So our answer to part B was the 2 different times that the ball was in the air. So let's have a think about what happens when we throw a ball in the air. It's pretty obvious. It goes up and then down again. So apart from when it gets to the highest point, it goes through each height twice. So that leads us to our answer, which is that the ball reaches a height of 4 meters on the way up and continues upwards, and then it falls and it passes through the height of 4 meters on the way back down. And you could add in it reaches a height of 4 meters after 0.6 seconds, and then it carries on up and falls back down and passes back through after 1 second. But I think you pick up the marks for what is written on the screen there. There are other things that we could write about what this situation is telling us, particularly with the work we've done on it, and we're going to turn that into an alternative part C. So they might ask, at what time does the ball reach its highest point, and how high is that above the ground? So, what do we think about this? Well, the height is represented by a quadratic, and these give symmetrical graphs, as was mentioned a bit earlier. So, that means the highest point must be when the time is halfway between the two times, that it's at a height of 4 meters. And to find halfway between two numbers, we find the mean of them. So, at 4 meters, t is either 3/5 or 1. So, the time for the highest point will be found by doing half of those two added together. So we've got half times 3/5 plus 1, which is a half times 3/5 plus 5/5, which is a half times 8/5, which is 4/5. So that's the time that the ball reaches its highest point. If we want to find out how high that is above the ground, then we need to put that into the formula for the height. So the height is 1 plus 8t minus 5t squared from the start of the question. So we have 1 plus 8 times 4/5 minus 5 times 4/5 squared. 1 is 5/5. 8 times 4/5 is 32/5. And then we have 5 times 16 over 25. Because 4/5 squared, we have to square the top of that fraction and the bottom. So 4 squared is 16, 5 squared is 25. And here we've got a nice thing that happens, which is we can cancel the 5 with the 25, and that means we've just got 5s on the bottom of all these fractions. That means we can add them all up quite easily. So we have 5/5 plus 32/5, take away 16/5, and 32 take away 16 is 16. Add the 5, that gives us 21/5, and if we wanted, we could say that's 4 1/5 meters. Or, as would be more normal, we could put it as a decimal, 4.2 meters. Okie doke. Bit of bonus material. What does this look like? Now, it's quite odd in a way, thinking about the height and the time as a parabola, or this quadratic curve is a parabola, because the ball itself doesn't travel that way. It could travel that way. That is the shape of what would happen if we threw a ball at an angle, but we can see here what happens with the actual ball and compare that with the graph that we've got. So if we sort of keep an eye on the red curve, we can see that the height of the ball is mapped against the time. So off it goes, and it's going up, and notice it's travelling with a steady speed left to right, which is of course the time, but it does follow that curve for its height. But now focus on the actual ball, and you can see that it is at the same height as the point on the graph. It's just going up, goes quite slowly at the top, and then accelerates downwards. And that animation was made quite simply on an app called GeoGebra, which you might have come across, and if you're going to study maths further, it's well worth a look.